Friends, in this video I'll be discussing about n queen problem. So the n queen problem is the problem of placing n chess queens on an n cross n board. Okay, so in the input there will be n indicating n cross n chessboard. So we need to find whether there is a solution, like whether there is a solution exists for two queens not attacking each other. Okay, so consider this. So this is the board of size 4 cross 4, and we need to check whether there is a solution or not. So if there is a solution, then print the board. And what does the solution contain? It contains the arrangement of queens such that no two queens can attack on each other. So we all know that queen can move in a row, column, and diagonal alignment. Okay, so suppose this is 4 cross 4 board, and now this is the solution. This is one of the solution, and in this manner we can arrange the queens such that no two queens are attacking on each other. So like in each column we need to place the queen. Okay, now see, in this area the queen is there in this column. Now we'll move to the next column, and again we'll place the queen such that it is not being attacked by any other queen in the board. So I hope that you got the problem. Now we'll be using backtracking algorithm to solve this. So now I'll be discussing the recursive flow of backtracking. Okay, so see, in each column we need to place one queen. Okay, so there are total n queens that we need to place over n cross n board. So we'll start from this point, from this column. And in backtracking, we know there are three things. There will be choices. So the choices are the column ranging from 0 to 3, and there will be constraints. So the constraint will be like in row and in diagonal. Okay, in row and in diagonal, there won't be two queens. Otherwise, they will attack each other. So these are the constants which we need to write it in a is safe function. Okay, and the third is the final solution, whether it exists or not. So if it exists, then print the solution. So our choices are the column number ranging from 0 to 3. So suppose I have called the solve function for this cell. Initially the column number is 0. So before placing the queen in this cell, I need to check whether it is safe or not. Before placing it in this, I need to check whether it is safe or not. Safe means whether this position will leads to a solution or not. Like placing the queen in this position will leads to solution or not. So this is the thing which we are going to do before filling it. So we'll call our safe function. This is the user defined function which contains the constraints that we are going to maintain in this problem. Okay, so it will call this save function, and it will return true or false. So true or false on the basis of whether there is queen in this row or whether there is any other diagonal queen. Okay, so right now there are no queens, so it will return true, and we can place our queen here. So suppose I have placed this. Now we'll recur for the next cell. So the function, the solve function will be recursive function. So we'll recur for the next cell, and again we'll start from our queen over here and call for the save function, and we find that save function return false, as because in this position the queen is being aligned with the queen in 0th position, 0 comma 0th position. So we'll iterate for the next cell. Again the save function will return false, as it is being aligned with this position diagonally. Again we move in this cell. So now the save function will return true, as because this is the position where there are no two queens attacking on each other. So after this, we'll go for the next column and again start placing the queen from this to the end one by one. So I'll place the queen in this position and call for the save function. Before placing, I'll check whether it is safe to place or not. So I'll call for the save function and it will return me false, as because already there is a queen in the row. I'll move in this cell. Again, the save function will return false, as because there is a queen in the diagonal. I'll move in this cell. Again, it will return false, as because there is a queen in this row. I'll move in this cell. Again, the save function will return false, as because there is a queen in this diagonal. So there are no solution that can lead to the goal. So what we need to do? We need to do backtrack. Okay. So the recursive function gets false and it starts to do backtrack. Okay, it will move to the previous caller of this column. So it moves to the caller of this column in this part and resume the iteration. So it has filled in this position. Now this position will be filled with the initial value, and will move to the next value for the iteration. So it will move over here. So before placing it over here, it will call for the save function. It will return true or false. So right now it is true, as because no two queens are aligned with each other in row and diagonal manner. So after placing it, it will move to this and again it will start from this to this. Okay, again it will start from this to this and start leading towards the solution. So this is the recursive flow. I hope you got this approach. So now I'll be talking about code snippet, which I'll be following in order to write the code in an organized manner. So already I've discussed about this backtracking code snippet, which helps to write code in an organized manner. So see, first of all, we'll be creating main function, and inside the main function, our user defined function, that is solve function, which will contain all the information required to leads to a solution. Okay, like it will contain n, which indicates the number of queens or n cross n chessboard, and it will contain the initial position, like from where we are going to begin with. So it will contain a column number, that is 0. So we'll start with column number 0 to column n. Now it will call to this solve function. So for as solve function is recursive, so there will be the base case. So the base case is like when our queen will be at the end, when our queen will be at this position, and the moment it will go to this, it indicates that we have placed our queen in the board. So the base case will be like when the column is greater than n, or when it is equal to n. So this will be the base case and it will return true, that yes, our solution exists. Now there are choices. So the choices are the column number. Okay, column number, it means like the queens, that is n choices are there. Okay, so there will be a loop which will provide the choice. So it will place the queen in the position. Now before placing it in the position, we'll call the save function. Okay, so the save function is outside this solve function. So the main role of this is to return true or false, whether it is safe to put the value in this position or not. So it will contain the rules, like what are the constants, like there won't be any queen in this diagonal, in this diagonal, and in this row. So we'll be checking only in this area, as because we are placing our queen in this part, and right now the queen has not been placed in this, so it is useless to check in this area. So we'll consider the area backwards, okay, in diagonal manner as well as in row manner. Now if the save function returns true, what we will do, we'll place the value in the position and recur for the next position. Recur for the next position means, suppose I have filled my queen over here. Now it will call for the next column. Okay, it will call for the next column. As this is the recursive function, it will call for the next column. Now if all the columns get filled with the queen, then it will return true, like the base case will hit and will move out of this and will return true, that yes, solution exists, and will print the board having the queen arrangement where two queens are not attacking to each other. Okay, so suppose in this column we are not getting any choice, like we are not able to fill the queen. So like this for loop will not work, and if this for loop will not work, we will reach to this return false case. So this return false will move to the caller of this column. The caller of this column is this one. Okay, the caller of this column is this. So it will move to the caller, that is to the solve function, and will start its execution from this point. So this solve contains false value. So what it will do, it will mark the position to the initial value. Suppose the initial value of the board is 0 and I have filled this position. So it will mark this position to 0 and will resume from the next position. Okay, and will resume the for loop, that is the choice from the next choice, okay, available. So this is the code snippet and recursive flow of n-queen problem.